Year 12. For the next few lessons here, we're going to have a look at graphing lines. We're going to talk about things like functions or relationships or equations. Right? We're talking about the connection or relationship between two different things. Simplest terms, X and Y, but it might be, cost and weight, or it might be time and distance or something like that. Okay, so here's some key words. We'll talk about those in class perhaps. Hopefully you know what lots of those are. We'll probably, by the end of this little topic, you should be familiar with each of those. Okay, so let's have a look here at the first part here, where we're going to be graphing some linear functions. Now, a linear function is this relationship between X and Y, and it makes a straight line, okay? A continuous straight line. Now, I've put these diagrams in here with a dotted line just so it's sort of easier to tell. What are the axes here? So these are number planes. Normally this would be, an X would go here and a Y would go here. Right? I have two axes, an X-axis and a Y-axis at right angles to each other. The X-axis is the horizontal one. You might remember an X looks like a cross and it goes across. The place where these cross over here, where the two axes intersect, is called the origin, and that has coordinates 0, 0. The X coordinate goes first. It's like the address for a point on that plane. Righto. So this equation forms a straight line. We can see here. So that's a linear equation. That's good. This one here, yes, that's a straight line. It doesn't have any sort of angle or slope on it. We might call gradient. It's a horizontal line. Nonetheless, it is a straight line, so I'm all good with that. Now this one here, certainly not straight. Now it doesn't matter that it doesn't cross this x-axis anywhere. It does matter that it's not a straight line, so not that one. Here we have a really special case, because this is a vertical line. It's not actually a function, but it is a linear relationship. Still a straight line, so let's give that one a tick. Over here, I have a straight line, that's good. And obviously here, not a straight line. Okay, so out of those here, I can zoom out a bit. I had, what do we have? 4 linear functions and 2 that were non-linear. Now, if we have a look at the equations that go with those things, mostly we see they're in the form y equals, right? But so is this one. So that's not enough to say that it's a linear function. This one says x equals, and we said that's still linear. It's not a function, but it's linear. This doesn't have an x in it, and that's why it's horizontal. Okay, so the changes in the x don't affect it at all. But anyway, that's identifying linear functions from their graphs. Now, to identify them from their equation, right, there's a couple of things here. It's mostly about what they can't have. So, we can have x's and y's, but I can't have any powers. I can't have squared or cubed or anything like that. No indices. Also, I can't have x times y together, or x over y, or y over x, or in fact, x or y on the bottom of any fractions. Okay, they're all problems. Fractions are okay as long as neither x nor y are down the bottom. So, let's have a look. This one here passes the test fine. That's good. This one here, now it's 2 minus x, right? We're not often the x part comes before we call this a constant part, but that's still fine. There's no powers there. X and y are multiplied together. There's no fractions that we've got to look closely at. Now over here, I have a fraction, but x is up the top in the numerator, so that's fine as well. That's still linear. Here though, because x is down the bottom of that fraction, not linear. Okay, that's a non-linear function. Now, x plus y equals 1. You have to be careful here where x and y are on the same side of the equals, but they're not multiplied together. They're not dividing each other. There's no powers, so that one, once again, is fine. Half x plus 4, we've got a fraction, but x isn't down the bottom, so that's fine as well. X squared here, that's a problem. Can't have powers, so not that one. And these are multiplied together, so not that one either. Right, that's how we identify linear functions. Firstly, by their graphs, and secondly, by their equations. The next thing we want to look at here is checking to see, does my graph, right, if I'm given a particular point, how do I know if my graph goes through there without actually drawing it really carefully? There are a few steps to this, so watch closely. We're going to test to see how this happens. What we're going to do, so we've got a line here, y equals 2x plus 7, and that's linear because neither the x nor y have any powers. They're not multiplied together or divided, and neither x nor y are in the bottom, in the denominator of a fraction. So this is linear, and I want to know, does it go through the point 517? And does it go through the point 0, negative 7? Well, let's check. We're going to have a look at the 517 first. I'm just going to write it here so I know what I'm doing. Normally you'd probably, I suppose, in a question only be given one of those, but we've got two here. So let's have a look at 517. Now, we know that y equals, right, remember that's the x and that's the y. So y equals 17. I know that part. And we could also say that's my left-hand side. The left-hand side is y, and I know that's 17. The right-hand side is 2x plus 7. And x in this case is 5, so that's 2 times 5 plus 7 equals 10 plus 7 equals 17. Right, and these two things, all good? The left-hand side is equal to the right-hand side, so yes, it does. It passes through 517. Okay, because the left-hand side equals the right-hand side. Let's have a look at my other point, 0, negative 7. We'll see what happens there. Now my left-hand side here, I'm going to say my left-hand side, slightly different to last time. This is just slightly more formal. My left-hand side is still y, and y in this case, it's not 0, y, remember x comes first, is negative 7. So my left-hand side is negative 7. My right-hand side is equal to 2x plus 7 is equal to 2 times 0 plus 7 equals 7. Are these two things the same? No, they're not. So no, it doesn't pass through 0, negative 7. Okay, righto, that's how we test to see if that equation, or sorry, we could say if those coordinates satisfy that equation, or whether that line passes through that point. Moving along now, if we have to draw a graph, right, if we've got an equation and we have to sketch it, a good way to do this can be a table of values, which I'm sure you've seen before. So we draw up our table with x up the top, y down the bottom. Normally we'll just make up some values for x. It's a good idea to have some negative numbers, some positive numbers for x, and 0. At the very least, try things like, negative 1, 0, and 1. You really want to have at least 3 points, right? Because if it's a linear function, you should only need 2 points, but the third one acts as a bit of a check. Okay, if those 3 points form a straight line, you can be pretty confident you've got them all right. If they form a triangle, then there must be a mistake somewhere. So at least 3, probably 4 or 5 is a good idea. So here we go. I have a table of values here. This one's already started a bit. I didn't have to make up the x values. Some have been provided. Here's my equation, y equals x minus 2. So I'm just going to, one at a time, replace the x with this number here. So if x is minus 1, negative 1, y equals negative 1 minus 2 is negative 3. If I say y equals 0 minus 2, then y equals minus 2. If I say y equals 1 minus 2, right, replace the x with this 1 here, 1 minus 2 is negative 1. And just be careful, right? We've had 3 in a row here. There's a bit of a jump here to the 5. 5 minus 2 is 3. So I've got a table of values now, and what that really gives me in this case is 4 points on my number plane. So I'm going to draw that up. You should use a ruler. Graph paper is even better. I don't have that here. I'll just be as careful as I can. Notice my axes have arrows on the end and an X and a Y in the appropriate place. Okay, it's a good habit to get into. Now, you can use graph paper, is great. You can measure these with your ruler, but don't go crazy, and sometimes it really makes it hard to fit. Just try to use a bit of common sense and label your points. It should be alright. So negative 1, negative 3. That means start here at the origin, go across negative 1 places, so that's over here. And then go up negative 3, which means go down 3. So that's going to be about there. There's my point there at negative 1, negative 3. 0, negative 2 is going to be about here. Across 0, up negative 2, which means down 2. Go across 1, down 1. This says go across 5, up 3. Okay, so I'll fudge these a little bit. It should be a case, right, and then I can line up my ruler, that all of these points form a nice straight line, and we can join those up here. It's not the worst one in the world. But anyway, and there's my graph. So we had an equation, we've drawn up a table of values to put some points, we join the dots together to get a graph. It is a really handy tool. Now, I'm going to ask you to do this one on your own, and I'll check out your work in class. Righto, so once again, you've got an equation here, table of value with 4 points. Choose some positive and some negative numbers. Nothing too gigantic. And try to generally avoid fractions and things. Just makes your life hard. Have a go at that. I'll come and check your work. Now, let's talk about intercepts and gradient. Okay, there's some fancy words that we'll find in that list at the start there. An intercept is where your graph crosses one of the axes, right? The x-axis or the y-axis. Where your graph crosses the x-axis, that's the x-intercept. Where your graph crosses the y-axis, it's the y-intercept. Right. Now, if you've got the graph, you can just look carefully and you can read those things off. That's great. Oh yeah, where the graph crosses the y-axis is called the y-intercept. Write that in there for me. Outstanding. Now, we have drawn a graph here, right? If we have drawn that really carefully, I want to read off the x-intercept and the y-intercept. Now, my x-intercept is where it crosses here, so what are the coordinates for that point there? Well, it's going to be 0. Oh, sorry, it's not 0. What am I talking about there? Okay, how far across have we gone? Well, we've got to interpret here, and if I've drawn it really neatly, I should be able to see, if I had a graph there, then that should be 2 steps across, right? We're going to cross 1 here and another one there. So we've gone across 2 and we've gone up or down 0. So my x-intercept is at 2, 0. Let's come down here and write this. X-intercept 2, 0. My y-intercept. Okay, let's have a look and see if we can read that off. My y-intercept is where it crosses the y-axis, and to get to this point here I go across 0, so it's 0, and it crosses at negative 2, so my y-intercept is 0, negative 2. Oh, good. Wonderful. Now, we can do this without a graph by substituting a number into our equation. If I want to find the x-intercept, I let y equal 0. I make the other thing 0. If I want to find the y-intercept, let x equal 0. Let's have a go here. I have an equation, y equals 3x plus 6. I want to find the x and y-intercept. So my x-intercept, I let y equals 0. Let's write that down. Now, means 0 equals 3x plus 6. Now, I've got 3 times something plus 6 is equal to 0. So, 3 times something must be equal to 6, so they cancel out and get me back to 0. 3 times what equals 6? 3 times negative 2. Right, x in this case must be negative 2. 3 lots of negative 2 is negative 6. Negative 6 plus 6 equals 0. Try the same thing with the with the y-intercept. To find the y-intercept, we let x equals 0. Therefore, y equals 3 lots of 0 plus 6, which is, of course, just 6. So my x-intercept is at 0, negative 2. My y-intercept is at, my x-intercept is negative 2, 0. X comes first. My y-intercept is 0, 6. Let's draw those on my number plane here. Again, draw this up as neatly as you can. I'm working on the computer here. That's not great, but ruler, pencil, graph paper is excellent. Righto, there's my x and y. So I've got this point here. It says go across negative 2 up 0. So that's my x-intercept, right? That is negative 2, that point there. My other one is go across 0, go up 6. There's my 2 intercepts, and because it's a straight line, I can draw a straight line. There's only one straight line that will fit through those 2 points, and that's what the graph of this equation looks like. You can see that was a little bit faster than the table of values. Not quite, it doesn't have that check of having a third point to make sure we've got everything right, but if you're careful, that's another way to graph an equation. Now, we were going to talk about intercepts and gradient. We know about intercepts. Just a little bit more. Just a little bit more. We used to abbreviate it to B, and these days, mostly it seems we're using the pronumeral C for Charlie, to represent our y-intercept. It's a special thing. The y-intercept is a bit more special than the x-intercept for whatever reason. If I write my equation in this form, and I will give most of your equations to you in this form, y equals some lot of x plus something. Right. That plus something on the end, or maybe minus something, that's your y-intercept. So, y equals 2/3 x plus 4 means my y-intercept is 4. Y equals 3x plus 6, my y-intercept is 6. Right, there we go, 6. We worked it out. That number on the end is the y-intercept. It's really easy to read off. It's often written as C. Righto, let's just quickly have a look at some of these where we've had other ones. What's my y-intercept here? 3. What's my y-intercept here? 4. My y-intercept here is tricky. Notice there's a minus x there. It's 2. My y-intercept here is 1. What about my y-intercept here? What's on the end? Well, nothing. So this has a y-intercept of 0. This linear function here passes through the origin, okay, because it doesn't have some extra y-intercept there. Rightio, we're getting towards the end of this now. There's the exercise I asked you to do. Here we go. Now let's talk about gradient. Gradient is slope or steepness. It's usually abbreviated for some weird reason to M. M for Mike, not M for gradient. Right, but gradient abbreviated to M for some reason. It's the steepness or the slope, a line that is going up from left to right, like this one here, up from left to right, has a positive gradient. Imagine you were walking along this line from left to right, you're walking uphill. It's a positive gradient. Down from left to right, it's a negative gradient. That means when you go along from left to right, it goes down, it's a negative gradient. A horizontal line, like one of the ones we had back here near the beginning, a horizontal line has a gradient of 0. It's not going up or down. And a vertical line, I can't tell you what that gradient is. Is that uphill or downhill? Could be either in some sort of way. Right? I can't tell you, so this is undefined. Remember we said that's not a function? It's kind of why that we don't give that the title a function, because I can't tell you what the gradient is on a vertical line. Horizontal line, gradient of 0. Now, one of the other things that you can use to understand gradient is if I'm following along my function, if I go across one step to the right, if I go across one, the gradient tells me how far up or down I have to go to get back to the line. Right, one step to the right, whatever I've got to, however far away I am from the line, right, up or down, that's my gradient. So here, this has a gradient of 6. If I take one step to the right, I've got to make 6 steps upwards. Righto. There's those things. You can read the gradient off an equation. It's the coefficient, the number in front of the x. So the gradient of this is 2/3. It's got a slope of 2/3. The gradient of this is 3. The gradient, let's find another one. The gradient of this is 1/2. The gradient of this is 1, because that's like a 1x, and so on. Right, that's gradient, and our intercepts. Finally, we can also, rather than doing these manually, there's lots of online tools that you can use for graphing. Desmos is a particularly good one. I could give you the link, but look, just search Google Desmos, you'll get there straight away, and you can just type equations in. So what I'm going to ask you to do now here at the end is to go to Desmos, type these in, see what they look like. Maybe experiment with all sorts of other weird things, see if you can get something crazy going on. Okay, have a look at what the equation looks like and the graph, and see if you can make a small change to the equation and see what that does to the graph. Right, look for things that these ones here, particularly the top ones, the top 5, what do they have? What do their graphs have in common? What do their equations have in common? What do their graphs? How are their graphs different? How are the equations different? Right, check that stuff out for a little while, and that'll do us, I reckon. Okay, thanks guys.